Hello everyone. This is an Aimsun video and I would like to get to the matrix estimation part, but before that I think there are some steps to go through first. So I would like to talk about the strategic modeling in Aimsun first, because we need to use those features to get the matrix estimation done and calibration. So before you start using the strategic model, you need to make sure that you see static macro up here. So if you click there, make sure that you select that. Otherwise, you won't see the options. When you do the strategic model, that is a very simplified version of modeling that makes the model run very fast. And that means that your model is not detailed a lot. The way strategic model works is basically it simplifies everything. And in Aimsun, you have certain cost functions. Cost functions deal with delays in the network that is there to represent a delay in a very simplified way. So there are three cost functions: a JDF or junction delay function. There is a TPF, a turning penalty function, and the VDF, volume delay function. Volume delay function needs to be assigned to sections, and JDFs and TPFs assigned to turns, not to nodes, to turns. Let's start with the VDF. So VDF is basically a volume delay function, and its purpose is to somehow give a calculated delay based on the capacity and the settings of that link or that section. If on that section you have high speeds, high capacity, more lanes, stuff like that, then the delay will be smaller. The higher the cost is, the more constraints you have on that link, the higher your VDF function will give a cost. There are also manual ways to change costs. So there are user-defined costs. Basically, you can penalize certain routes using these user-defined costs. You can just add that to your cost calculations. In Aimsun, there are example costs provided by the developer, but usually many people use their own based on the project. They are written in code, usually in Python, but by default, the examples are also provided in a Lua language, but usually it's Python. You can edit and you can basically check each of them, what they do. TPFs are usually simple ones. JDFs are usually more complex ones. You can also show the cost. You can draw it. I don't show it yet because you need to have an experiment, so you need to have actual data in it. But you can use it until it will draw the function how it changes depending on the flow, for example. But be aware that this window here, when you use this draw, is quite buggy, and usually it doesn't show the correct output. So if you want to evaluate or you want to see the actual costs calculated by these functions, you need to go into the editor here, and you need to use a print function to print out into the log window the actual cost. So as you see here, it's also in the comment. So if you just remove that, then it would print out for that turn or that section or anything that you use that cost. So let's go then into the detail a bit. So I talked about the VDF, that's very simple. TPF and JDFs, so they both assign to turns. So that and that and that separately. The TPF is, as it is called, so like a turn penalty function. What it does, it tries to represent the delay the turn causes. So if it is a normal non-signalized intersection, just like, let's say this, like a straight movement or a turn somewhere like here, and just assume that this road there is a curvature there. You need to slow down, and the TPF will provide you a delay that is representative of that slowdown effect. In here, or maybe in a different intersection where I already have some giveaways. So you can see that the east-west is the main flow and the minor is the north-south. So in this case, for example, here, this left turn gives way to no one. So in here, your TPF is basically just the reduction in speed and the delay, a number basically representing the delay, going to be your TPF. But when you need to give way, then you lose some time due to this drop in speed because you turn, but you also need to consider the fact that you need to give way to the other movement, and that depends on the conflicting movement or flow. That's where JDFs comes into play. So JDF function will take this turn's flow and it will take the opposing flow and it will calculate a delay from it. When you have a signalized intersection, then in a TPF you can use a signalized TPF or a signalized turn penalty function that will take of course you can make your own, but usually what it does, it takes the green time split within the whole cycle, within a given time period, how much green time that turn has. So like if in every, let's say 1 minute, you only get like 20% of the time is green for you, then it will return a number that represents that delay that is caused. And the way it works is that routes paths vehicle take will have JDFs, VDFs, and TPFs. So it will basically add up. So like this section has a VDF cost of, I'm going just to say number 1, has a TPF cost here of 2. Then this section again has a VDF. So far that route has a total cost of, let's say 4, if I can, or 3. Doesn't matter. Then you will have another turn penalty function here and so on. And if you get to a signalized intersection, for example this one, if assuming this is a signalized one, then it would have a JDF there, a TPF signalized, or if it gives way here, then you would have a JDF. So that's why a JDF is a junction delay function, because in a junction you basically give way, one gives way to another. So a JDF won't apply to every single node in a every single turn in a give way node or an intersection. It would only apply to turns that needs to give way. So this one, and so on. So if I go and edit a node, what you need to do is when you edit a turn within a node, you go to static model, and in the static model, you need to assign a TPF and a JDF. If you don't give way, assuming that one, so this one, edit turn, static model, then you would have this unsignalized intersection JDF, but you can even remove it because this one doesn't give way to anyone. So you can just click none, or you can create your JDF in a way that it will return basically 0 or a very, very, very minimal number. because it doesn't need to give way to anyone, and so on. And the same goes to the section. When you go there, there is in the static model, there is a VDF, so you select that your function, and that's the way it will work. And when you run your assignment, your macro model, your macro assignment or static assignment, it will use these functions to calculate. And as I said before, you can always edit these, create your own one, and with that it will calculate the total cost of the routes. And for each OD pair, so assume from here you go to here, there are different alternative routes, and then the cost will be different for each one. And that's the way it will decide which route is the more, the best one, basically with the least amount of delay and so on. And as you run the simulation more and more time, like iteratively, then vehicle will change different routes. And of course, in each intersection, a vehicle will meet, will have a different conflicting flow depending on the route choices. So that's why it will change every single time you run it, or every single simulation run, basically, until it balances it out and then your model has converged. So that's the idea behind it. I hope it wasn't too confusing or it made sense. Let me know if you have any questions in the comments. Also, if you enjoy these videos, please consider liking, subscribing. And in the next ones, I will try to get closer to a matrix estimation. I already showed in a previous one how to import RDS, survey data, so I'm going to get there, so then we can run an assignment on it, and we can see how we can change the metrics based on our survey data and calibrate it. And thanks for watching, and see you in the next one.